Okay, so hopefully we did okay yesterday with dropping an object and throwing it down. Today we're just going to look at what happens when you throw an object upward. So in this time we're going to have a velocity that's up, or initial velocity that's up, and gravity, the acceleration due to gravity, is still going to be down. So the sign on velocity is going to be positive, and the sign on the acceleration is still going to be negative 9.8 meters per second squared. And gravity is still going to change the speed of an object by about 10 meters per second each second. So if I were to throw an object up, and let's say we threw it up at 30 meters per second, now is gravity going to cause it to speed up or slow down in this case? Initially it's going to slow down on the way up, and then it's going to speed up on the way down. So if gravity changes its velocity by about 10 meters per second each second, then after 1 second of rising, its velocity will be 20 meters per second. And then after 2 seconds, its velocity will be 10 meters per second. And at 3 seconds, okay, at the very top, it's going to be stationary. It's going to be 0 meters per second. And that's something that's critical to know. At the very top of the path, the velocity, or at least the vertical speed of an object is 0. Okay? Then after another second of falling, now gravity is going to start to speed it up, and it's still going to change it by 10 meters per second, so its velocity would be negative 10 meters per second after 4 seconds, and then negative or down 20 meters per second, and then negative 30 meters per second over here, and then negative 40 meters per second down here. So gravity's still doing the same thing, just we're throwing it up instead. So these have a little bit of different type of problems to them. Okay, so how far above my hand will the rock have been after it traveled for 1 second? Well, so let's see. Its initial speed was 30 meters per second. Its final speed is 20 meters per second. That means its average speed was 25 meters per second. So that means that if it's been moving on average at 25 meters each second, and it did that for 1 second, that means it'll be 25 meters above my hand. Okay. After 2 seconds, let's see. And so my initial speed is 30, and you're going to have some tables where you fill in this this kind of logic, although it'll be in a table form. So if I throw it up at 30, and after 2 seconds it's going to be moving at 10, see, the average speed is going to be 30 and 10, so that'll be 40 divided by 2, it'll be 20 meters per second. So at the average speed is 20 meters per second, and it was rising for 2 seconds. 20 times 2 is 40, so it'll be 40 meters above my hand, etc. Okay, let's look at a couple problems here. I've got 4, I believe, I want to work. So a rock is fired upwards at 53 meters per second. What's its velocity 2 seconds after being launched? What's its velocity and how high will it be? Okay, so we launch our rock or rocket, whatever, ball up at 53 meters per second, and we've got a time of 2 seconds, and we want to figure out how fast it's moving and how high it's risen. We're going to be doing exactly what we did kind of in our heads, except we're going to be using the equations to do it. So if we want to know the velocity here, we're probably going to use our V2 equation. That's equation 3. So V2 equals V1, okay, plus negative 9.8 times our time, which is 2, and we get that V2 is equal to 33.4 meters per second. Now, in B, it asks how high it is. So when we're looking for height, we're looking for displacement. And when we're looking for displacement, we've got to know the time and the average velocity. So we don't know the average velocity. I know an initial velocity, and I know a final velocity, but I don't know the average. But we can find the average, add them up, divided by 2. We get average is 43.2. Then we use our equation 1, and we multiply the average velocity by 2, and we get our displacement, which is 86.4. So that's how high it'll be, the displacement, delta y. Let's say we look at the same rock, and now we're going to look at it 6 seconds after it was being launched. It'll be the same type of problem, just different numbers. So here we've got our rocket, and this time it looks more like a rocket. Check that out. So So here we launch it up at 53 meters per second, and after 6 seconds we want to know V2. So we're looking for the V2, so V1, we use equation 3, V1 plus A times T. So plugging in those, acceleration is always 9.8 in these rock gravity problems, rock, etc. And we get that V2 is equal to negative 5.8. So what does that mean, the fact that the velocity is negative after 6 seconds? Well, that means that it's already gone to the highest point and it's starting to come back down. So it's moving downward, so it's crested the peak and it's coming back downward. So again, we want to figure out its displacement, how high it is. So that means we need to use equation 1. And in order to use equation 1, we're going to have to use equation 2. So 53, our initial velocity, plus our final velocity, divided by 2, it gives us 23.6. And then using equation 1, multiplying that times 6, we get 141.6 meters. So very similar problem to what we did previously, just a little bit longer time so that it was on the way down. In the previous problem, we caught it on the way up. On this problem, we caught it on the way down. Okay, so what do we know about the object when it reaches its highest point? What do we know? Well, we know two things about it. We know that the velocity is 0, and we also know the acceleration. I'm not sure if this is a test question or not, but it could be. What's the velocity at the top? Positive, negative, or 0? The velocity is 0. What's the acceleration at the top? Positive, negative, or 0? Negative, because gravity is still pulling it down. So it could be a test question. You never know. So let's see. So the velocity. So if we wanted to figure out how high this rock went, let's ignore that. So let's say we got 1 second up, 2 seconds up, 3 seconds up. So if we launch it from the ground, if it takes 3 seconds to go up, it's going to take 3 seconds to come back down. So if it's in the air for 6 seconds, you know that it took half that time going to the top. So it would have taken 3 seconds to reach the top and another 3 seconds to fall back down. So make a mental note of that. You need to know that. So velocity at the top is 0, and the total time in the air is just half the time to go, or is twice the time to go up and twice the time to go down. Okay, so okay, and another thing to notice is that when it reaches the ground, the velocity is almost identical to the way when it was launched. So it was 30 meters per second here. What's different about the velocity when it comes back down? It's still 30 meters per second, but it is pointed down, so it would have a negative velocity just before it reached the ground. So negative 30 meters per second. Okay. So it used to be popular. I don't know if people still do it. If they want to celebrate an occasion such as New Year's Eve, they go out and get their guns and they shoot them up in the air. And what does this tell you about a bullet when it comes back down and comes back down to the earth? Well, if there was no air, it would come back down at the exact same velocity that it left the rifle with, so that full muzzle velocity. Truth be told, the air does slow it down. The Mythbusters did do a field test of whether or not you would die from a bullet shot straight up. And what they found was that if you shot it straight up, it probably wouldn't kill you when it came back down. But if you shot it kind of at an angle, so that it could follow a parabolic path, kind of like a football, because it spins, and that keeps it pointed the right way, then I believe it could kill somebody if it hasn't already. Okay, so the velocity at the top is 0. The time up is the time down, assuming that we're starting and ending at the same elevation, and the total time in the air is twice the time it takes to go up. So that's what T up means, the time it takes to reach the highest point, T up. And then there would be T down too. Okay. So we've already asked you this question. The velocity is 0 at the top. What's the acceleration? Still negative 9.8. Okay. So here's an object. This is a velocity versus time graph for an object that was thrown up in the air. So here In this region, we're in the positive region, the positive velocity. And that means it's moving forward, or in this case, up. And it's slowing down because it's approaching the 0 line. This is when it comes to a stop. Okay. This is when it starts moving backwards, or down in this case, and it starts getting faster and faster. So this is a velocity versus time graph for an object that was thrown up in the air. Where is it at its highest point? It's at the highest point when the velocity is 0, which would be right here. Okay, I think we got that. So the speed at the highest point is 0. The speed when it reaches the ground again is the same as the speed at which it left. The time to go up is the same as the time it takes to fall back down if it's on level ground, and that's half the time, the total time it's in the air. There we go. Okay, let's work 2 problems, or maybe 3. So we throw a rock upwards at 44 meters per second. How long does it take to reach the highest point? How much time does it take to fall back down? How much time is it in the air? And what's the velocity when it reaches my hand again? Okay, so this is our picture. So we throw a rock up at 44 meters per second. And sometimes it does help to draw a picture. Even a simple picture can kind of help solidify things in your mind. So, and obviously, if you look at my pictures, they don't have to be spectacular, artistic. And it's reaching the top. We know that the velocity is 0 there, and then it's coming back down. So what we want to do is figure out the time it takes to reach the highest point. Okay, so what we're going to do is, we know V1 is 44. We know A, and we also know V2. V2 is 0. If we start our picture here, this is V1, and if we stop our picture here, this is V2. Okay, so we're going to ignore the other half of this because we're going to consider our final location just at the very top. So, and we're trying to find T. Well, what equation has got V2, V1, A, and T in it? Well, that'd be equation 3. And that's the equation that we'll use to figure out how much time it's going to take to reach that highest point. So V2 is 0 equals V1 plus AT. Okay. And what we ended up doing was taking the initial velocity and dividing it by 9.8. That's kind of the shortcut, and that gives us our T up. Okay. So if it took 4.5 seconds to go up, B is how much time is it going to take to fall back down. Well, that's the same. Okay. C is what's the total time it's going to be in the air. Well, that's 2 times the time it took to go up. So it's 2 times 4.5, which is 9. And D, what's its velocity just before it hits the ground? Well, it's going to be negative 44 meters per second, just 44 meters per second pointed down. So that is one example. Okay, 2 more examples. A bullet is fired up at 140 meters per second. We want to figure out what's the time it takes to reach the highest point, what's the time going up, okay, to reach the highest point, what's the average velocity on the way up, how high did it go, and how long was it in the air. Okay, so again, we've got a spectacular picture. 140 meters per second is what the velocity that it was launched at. It's reaching the top. We know its velocity is 0 at that point. And the first question is, how much time did it take to reach the highest point? Okay, we're starting out with equation 3. That seems to be pretty common, is starting out equation 3. V2, which is 0, because our final velocity here is 0. Our initial is 140. Okay, we're starting and ending our picture here. We're ignoring this side right here. Okay, so V2 equals V1 plus AT. And you solve and you get 14.3 seconds. That's your time to reach the highest point. B is what's the average velocity on the way up. Well, it started at 140 meters per second. And then when it reached the top, it was moving at 0 meters per second. So that's just 140 plus 0 divided by 2 is 70. How high did it go? So now, again, we're looking for displacement. And if we're looking for displacement, we need to know the average velocity and the time. Well, we know the time. That's 14.3 seconds to go from here to here. Okay. We know the average velocity is 70 between here and here. So if we want to know the displacement between here and here, we just use equation 1, and we get the displacement is equal to 1,000 meters. So that's how high it went. And the last question is, how much time did it take to fall back down, or how much time was it in the air? That's just the time up times 2. So 28.6 seconds. Okay, last problem. We're going to shoot a golf ball straight up, and it takes 10 seconds to come back to the ground again. How long was it traveling upwards? What was the velocity when it was shot? And how high did it go? Okay, now this problem is a little bit different than the last one. Which is why we're going over it. So, golf ball, 10 seconds. Okay, so 10 seconds to come back down. So that means the time was equal to 10 seconds to reach here. That means it took 5 seconds to reach the highest point, where we know the velocity was 0, and time was 0 over here when it started. So how much time did it take to reach the highest point? Well, that was just half that, so 5 seconds. And then this question, we're going to use we'll use this equation a little differently. Equation 3. We're trying to figure out how fast it was moving here. So this is going to be our V1. So V1 is what we're looking for, how fast it left the ground. And this is still going to be our V2, and we're going to ignore the rest of this. So we're going to ignore the last 5 seconds and just go from 0 seconds to 5 seconds. So, so we're going to use equation 3 again, and we're going to say 0, which is V2, equals V1, which we're trying to find, plus A times T. Now we use 5 seconds because it's 5 seconds from the bottom to the top. Okay? And we get that our V1 was 49 meters per second. Then C, it says what was the average velocity on the way up, or how high did it go? I guess if it's looking for how high it went, we need to find the average velocity first. So equation 2. So we started at 49, and at the top it was 0. So we're really ignoring the second half of the picture here, just going from start to finish. So we get 24.5 meters per second. And again, we'll use equation number, that's equation number 1, not equation 3. That's equation 1. So V bar equals delta y over t. And again, we use our time as 5 seconds because we're only looking at half the picture. And we get 122.5. Okay, and that is where we're going to end it for today.